press record. All right, welcome everybody to our closing session of the interoperable description of observable property terminology working group. So the agenda is I'll first make a brief presentation of the aims and outputs of the working group. Then Barbara will present the interoperability framework, which is one of our key deliverables. Then Circo will talk about the catalog of terminologies. Then Barbara will present some of the recommendations from the working group, which is still work in progress, as well as some implementations of a scenario for the IADOPT framework. Then we will talk about 3 adoption use cases that are ongoing. So the first use case is CF standard names, CDataNet, and the NERC vocabulary server, which I will be presenting. Then there's Barbara will talk about the ELTER long-term ecological research standard observations implementation or adoption case. And then Robert Huber will talk about the adoption of IADOPT framework within Pangaea. Then we will have 15 minutes for discussion, or any time we have left for discussion, hopefully, and to discuss the interoperability framework as well as the use cases. And then we will have 10 minutes to talk about the connections we could have with other working group within RDA. Also connection we have already or we will have in the future, as well as any future plan we have for the work of the working group, which will carry on beyond the life of this working group. And then finally, we will have 5 minutes to wrap up. So for those who don't know us, we are IADOPT, which stand for interoperable descriptions of observable property terminologies. So our motivation is to address the I of FAIR by enabling interoperability between existing terminologies and also promoting the use of FAIR terminologies to annotate research data with well-identified, unambiguous, and machine-readable vocabularies. So our working group officially started in 2019. So we are now finishing off the work, but we started meeting well before that on a regular basis under the auspice of VESIG interest group. So the group is led by 4 co-chairs, Barbara Magagna, who is here today, myself, Anusuriya Devaraju, based in Australia, who couldn't make the meeting, unfortunately, today, and Maria Stoica, based in the US, who also, for who the time was really inconvenient, so she couldn't make the meeting today. We also had regular contribution from Circo Schindler, who is here today, and Alison Pamment. And we refer to this group as the core IADOPT working group members. But we also had regular contribution from many others, and many of you are here today as well. So the focus and scope of our working group is what we call the variable. So we started initially referring to it as the observable property, but there was some confusion about the use of that terminology. So we decided to settle for variable. And this is sometimes referred to as parameter or observation type or trait or measurement. But in IADOPT, the variable concept represents what has been observed independently of where, how, and when the data acquisition took place. The where, how, and when are provided by existing upper ontologies and conceptual models, like observation and measurement, for example, or SOSA, OBOE, schema.org, etc. So the purpose of the interoperability framework is to capture the necessary elements to fully and unambiguously identify a variable in a discipline-neutral way. So for the lifetime of this working group, our focus was on environmental sciences, because most of our background of the members of this group background is in environmental sciences, but we believe there is a potential to apply the framework more widely. So what are we trying to solve? Well, on one hand, we've got data creators and primary curators of data. We want to annotate scientific variables with fair semantics. Fair semantics that are domain specific, that are precise, unambiguous, machine readable descriptors of what is being measured or observed. This results in a high diversity of specialized terminologies that are seldom aligned across domains, and they are not always compliant with basic fair semantic requirements. On the other hand, we've got the data users who want to discover data. They want to maybe analyze, harmonize data from different sources. They want to aggregate multiple channels, multiple data streams into one. And again, this results in a requirement for diverse terminologies needed to cater the range of terms that end users expect and that their applications need. And the requirements from those two types of users are different as well. So basically, diversity, specialism, and precision in terminologies are needed, but disparity is a problem for interoperability. So we really need to connect them systematically. And for this, we need this interoperability framework that we've been working on for the last 2 years. And this will enable to develop semantic tools, including converters, semantic brokers, connectors, semantic bridges, and dynamic mapping tools in general. And this, as a result, will enable us to label, annotate, identify, discover, align, compare, harmonize, and aggregate data. So cater for the whole range of services that users would like to see. So our methodology was, we first started in parallel running 2 tasks, which was to collect user stories from stakeholders, so from users of terminologies and from creators or managers of terminologies, and also to collect conceptual information about conceptual models and terminologies that were already in place. So for the user stories, once collected through a survey, we transform them into use cases, so formalize them into use cases, and from which we derived a functional requirement for those use cases. And in parallel, from the information collected from the existing terminologies, we identified the requirement that was needed for that, as well as the key elements that were common to all those terminologies, especially the ones that were already modeling what constitutes a variable or a measurement. And this helped us define the IADOP framework. We then did a series of iterative steps that enable us to test the framework and refine it. And we are now at the final stage where we're basically writing all this up, and as well as developing design patterns and also testing the framework within implementation or adoption use cases. So the user stories to user use case to functional requirement is summarized in this table. We've got 15 use cases, and we group them into 4 main use case groups. The first one, terminology generation and management. The second one, resource annotation. The third one, data discovery and exploration. And the fourth one, data manipulation and integration, which take those themes I was talking about earlier on in the presentation. So the survey of terminology brought us information about over 100 terminologies. Some of them were, well, they were very diverse. Some of them very narrow, in their subject area. Some of them were more generic. Some of them addressed just one element of what an observable property is. Others considered the full modelization of the observable property. So then we, with regards to the IADOP framework, we took all the terminologies that had already worked on modeling the observation, and we extracted the common elements from those terminologies. Initially, what you see on the screen here is a very simple end product of a very complex process. And I must say that we had a series of workshops in March 2020, and those were crucial in helping us clarify the model. So I think a huge thanks to all the participants of those workshops, because that was a crucial process in us delivering this much simpler model for the framework. So basically there are four classes. We've got at the top, there is a variable that we are decomposing effectively. And it's this decomposed into its property, into a series of entities, or one or multiple entities, and I will come back to that, and it can also have a constraint. So the entities can take different roles. The main entity will be an object of interest. So a variable will always have a property and an object of interest. And that object of interest can be embedded in a matrix. So matrix is another important role. And then we've got provision for context object, which are associated with the object of interest, but not directly, but need to be considered separately.
I think we have to be a bit quicker. And
I'm
going to tell this in more detail. Anyway.
What's the time now, Barbara?
It's 1:15.
Okay, so we've got, So Barbara is going to talk about the framework later, so I pass on that. So this is my final slide. So the key output are the IADOP framework, which is ready. We are testing the adoption of use cases, and we're inviting feedback at the moment. Then we've got alignments with other ontologies, which will be an ongoing task, but we're inviting comments and contributions on what has been done already. Then we've got the IADOP catalog of terminology, which Circo is going to present after Barbara. Then we've got the variable design patterns, which is work in progress. The catalog of implementation, again, work in progress. And then we've got our draft recommendation document, on which we will be inviting comments. So that's, I'll stop sharing and pass on to Barbara.
Yeah, hi. So I will now continue with my presentation. I have to check if I can. 1 moment. I'm pressing the wrong thing. Okay, give me a sec. Okay. So I hope you can see the whole slide. Yes. Okay, I'm going to present the IADOP interoperability framework, and I'm checking how I can move forward. I can move forward like this. Yes. So as Gwen already said, our aim is to have to avoid a proliferation of variable descriptions all over the different terminologies, because unfortunately it is really hard to map the different properties in the different resources, because they are using different concepts behind. So for very simple variables like wind speed, this is easy, but they can become very complex, and then it's really hard to do it right now. So therefore we have minted the variable concept, which is a representation of a combination of descriptive components, giving meaning to the value derived from any type of acquisition event. It could be an observation, a measurement, a simulation, a calculation. And as Gwen already said, we are focusing on the what, and we are not including the where, how, and when, although there are some exceptions where we include some of the how information into the constraints. But the more important thing is that we are only having concepts for types. We are not instantiating an observation, we are describing an observation situation. So you have seen that already, but now I'm using our running example, which is the mean concentration of endosulfan sulfate in wet flesh of Ostrea edalis at a specific location, in this case Emerald Coast, in this microgram per kilogram. So this is an observation, a full observation description, which is our starting point. We are looking at that and trying to derive what is the variable, the observable property part. That's the yellow in the middle. We exclude the feature of interest, so that or the feature, where this has been really observed. So the emerald sea coast. So we are not looking at the location, and we are not looking at the process or the procedure. We are just describing the what, and this would here include concentration of endosulfan sulfate in wet flesh of Ostrea edalis in microgram per kilogram. So so first is we have to try to decompose it in single logical unit elements. So if we include also mean, there would be a mean for the statistical measure, the concentration, endosulfan sulfate, wet flesh, Ostrea edalis, and the unit. But when we discussed this in our workshops early March, we found out, well, this is not really what we want. A variable should be a reusable concept in different contexts, and therefore we said that the unit should not be included, and also not the statistical measure. So we then would have only concentration, endosulfan sulfate, wet flesh, and Ostrea edalis as the components we are looking at in IADOPT. And for each of these components, we have then to find appropriate concepts from a semantic artifact, from our terminology, and we can use our community-specific terminology, but also any other which seem to be appropriate from ENVO or NERC vocabulary. I'm from the ELTA, long-term ecosystem research. I would use ENVDES as the main source, but I would also look into other terminologies that might be helpful here, like the NERC vocabularies. So this is just to introduce how we approach this, and this we were then able to produce an ontology, a very simple ontology, which is published at this site that you can approach from the slides that I will then share afterwards. So we have the variable, that's the green box, which is a concept that holds everything, each of the components in it, also in the label. And a variable is decomposed into several atoms, which are in this case a property, entities, and constraint. Entities might have different roles. As you can see, these are described here via association. So an entity can have an object of interest role, a matrix role, and a context object role. And the variable has at least one property, but only has one property of one object of interest. So this is a one-to-one cardinality, but it can have in addition a matrix where the object of interest is embedded, and it can have more than one context object. And the variable might also contain a constraint or have a constraint included, and this constraint can apply to any of these entities. So the constraint can constrain the object of interest, the matrix, or the context object. So this has created some confusion, as I have heard. So a variable is composed out of these elements and also of a constraint sometimes. And if the constraint is added here, it is important to know what exactly is constrained. Not the whole variable, but only parts of the variable are constrained. And this might be the object of interest, the matrix, or the context object. Or you can have also more constraints. So this is another view on the same conceptual model. So just another possibility to implement it. So in this case, the entities are specialized into object of interest, context, object, and matrix. So these are all classes in this case, but I find it difficult to implement it like this because a variable can have different entities that can have, or the same entity can have different roles in different variables. So an entity can be an object of interest in one variable description, and in the next it can be the context object. Therefore, I find it not really useful to define them as classes, but just as roles. So a variable is a description of something observed or derived, minimally consisting of an object of interest and its property. So at the minimum, we have this. And we use now always this running example to really understand how this is built. So the concentration of endosulfan sulfate in bed flesh of Ostrea edalis. So where we don't include the unit or the procedure or anything else, also the location. So it's a variable type. So the variable is really including the whole description here, concentration of endosulfan sulfate in bed flesh of Ostrea edalis. But this has at the minimum an object of interest and its property. The property is a type of a characteristic of the object of interest. So in this case, the concentration. And it has an object of interest. So a variable has an entity whose property is observed. So it's endosulfan sulfate in concentration of endosulfan sulfate. These are this is easy to identify because it's the concentration of this substance in wet flesh of Ostrea edalis. The matrix is the entity in which the object of interest is contained. So in this case, it is the flesh in that variable, and it has a context object which provides additional background information regarding the object of interest. So the Ostrea edalis is the context object for the wet flesh. So we have to to indicate what where this flesh, this part of organism is or part of. So the wet flesh is part of the species Ostrea edalis here. You can see how we have, the constraint the constraint is also a component of this description. So a constraint limits the scope of the observation and confines the context to a particular state. So it describes properties of the involved entities. In this case, it is wet. So wet constrains the flash, so the matrix in this case. But we can also have other types of constraints, like at a specific temperature, or in a dissolved state, or at a specific pressure. And here these are from observations themselves, fixing other properties that influence the main observation considered. The entity, as I said, is the class that we use for any type of element that has different roles in this description. The roles can be object of interest, context, object, and matrix. This can be the body, atmosphere, nitrogen. Also important, we are not only including objects here, but also processes. For example, erosion is a process, and this can be also an object of interest. And here you see how we have implemented this I have also implemented this in ENFTES. This is the Barbel has this this concept URL, and it has different normal SCOS properties, like product concept. So it is the product concept is concentration of substance in the organism, but it has also additional associations that come from the IADOPT ontology, and this is has property, which in this case is concentration. So the concentration is also a concept that links to a specific terminology. Here you can see that you don't see the URL, the URI, because it's already part of ENFTES, so concentration has a URI. But there has object of interest here. I use a concept from the NERC vocabularies. So the endosulfan sulfate matrix, I'm also using that from the NERC vocabularies, and matrix, and context objects. I am using a concept from the marine species, the Ostrea edulis, and so on. So this is how we are describing and implementing a Barbel, IADOPT Barbel in Thesaurus. So the IADOPT framework has the benefit that we are really helping to semantically describe Barbels in a precise and fair manner. By decomposing description into atomic components and linking those to existing vocabularies, we make these descriptions machine readable, and we provide abstract, reusable semantic descriptions that can be really used in different contexts for concrete observations. In this way, we allow straightforward mappings between Barbel descriptions across terminologies. They can exist as they are, but they should include additional associations using the IADOPT ontology. And in this way, we provide rich human and machine-readable descriptions with qualified references. So targeting the I3 fair guiding principle and finding a good solution for it. So I would then stop here and give over to Sirko, who will talk about the catalog of terminologies that are needed, which is a resource needed really to instantiate our elements, components of our Barbel description.
Okay, then let's see. You should be seeing my slides now, I hope at least.
Yes.
Right. So as Barbara already mentioned, one of the integral parts of the model is then the instances you need to actually describe your variables. So to develop this kind of repository of terminology is giving you some kind of overview, what kind of, or what terminologies are already out there to decompose your variables. We use the multi-stage process. So in the beginning was the survey that Gwen already mentioned, which gave us round about 100 terminologies that are somehow related to the task at hand here. In the next step, we took all those terminologies and tried to analyze and classify them further. So we had a look, besides the information that we asked from you in the survey, we also had a look like what type of terminology is it? Is it just a scarce vocabulary? Is it the full-fledged ontology? Is it the controlled vocabulary, etc.? Similarly, we look for the languages, for the elements included, and anything else that might be useful to know about such a terminology before using it. And then now finally, to make this information available, we've created a repository and a according web page to allow you to actually search for terminologies that might help you in describing your particular data. And now I would like to show you how it currently looks like. So I've put the links already in the collaborative notes if you want to explore it on your own. Now, from my side, just a quick overview. This is the starting page of the catalog, which gives you, again, our basic model. And here then the link for the actual list of terminologies. This takes you to a complete list of terminologies that we currently have in the repository. This is not all the stuff that we collected in the survey, as after analysis, some of those terminologies that were submitted then didn't really include instances to fill variables later on. So those are excluded here. All the terminologies that you find here include at least some of the instances you might need for decomposition. And then this is the grand overview. You have just name, domain, and the type. And then if you click on one of those terminologies, you get a more detailed view, giving you, again, URLs where you can find this actual sources of this terminology, the domain it belongs to, a bunch of keywords, the languages it is available in. And then here on the bottom, you see all the components of our model that this terminology supports. So in this particular example here, you won't find anything giving you already full-fledged variables. Variables here in this case doesn't mean decomposed variables, but just variables in general. And then all the other classes like property, entity, constraint that we've seen before. And in addition, we also collect here whether they include instances for methods or units of measure. One thing to note here, the domains here are not arbitrarily, but we try to classify them according to the EuroCyVoc, which is a vocabulary of the European Commission to classify or to build a hierarchy over sciences and other research areas. To ease the navigation in through the terminologies, the list of terminologies can also be filtered. So what we saw in the beginning was the full list of terminologies. But as you see up here, we have also links for all these subtypes. So if you're just interested in finding terminologies that allow you to describe some constraints, you can click on the top, and then the list will be filtered down to those that actually contain some kind of constraints already. As you can imagine, such a repository is never really finished. So as a means of maintenance, we chose to have a GitHub repository. So I hope you can at least partially read that. Link again in the collaborative notes. And this is how we imagine currently to maintain this repository in the future. So besides all the code parts that are here, which are most likely of no interest to most people, we have this data folder. And here in this data folder, there is a file for each of the terminologies. And if we look into, this should be the same one as before, This is pretty much the same information that we've seen beforehand on the web page. So in case you spot any error on either on the page, or you feel that some vocabulary is missing, you want to add your terminology, please feel free to submit a pull request, just adding your terminology in such a file or correcting the file of whatever terminology you spotted the error in. Make a pull request or an issue, and then we will immediately incorporate it into the repository. Right, and yeah, one thing which we didn't see in the example before is down here. So we also tried already to collect alignments across the terminology. So if the terminology is already possesses mappings towards another ontology, this is some of the information that we try to collect here as well. And then as a final point, for those that may want to use that information also in an automated pipeline or something, you see here in the end, there's 2 links giving you the same information also as in a JSON encoded format or in a RDF encoded format based on DCAT. And that's it for the repository. And I'm giving over again to Barbara, who will continue with the recommendations, I think.
So are there any questions for Sirko about the catalog? If not, I continue with the recommendations. Do you see this full screen? Yes or no? Gwen?
Yes.
Yes, we see Barbara.
Okay, fine. Okay, as Gwen already said, this is a draft at the moment, but this comes from our experience using the IADOPT framework. So when you are modeling a new variable, we invite you to follow this step-by-step guide. So first, you need to have a deep understanding of the phenomena you are going to describe. You either are the researcher who investigates in this subject, or you have a domain expert at your hand so that you can really understand the nature of your observation. Second step is to analyze what components, so reusable atomic parts of the variable descriptions, are really needed to describe your variable to be fully understood, but omit the unit, the method, and the statistical measures. So really, identify these parts. For our running example, it's concentration, substance, part of organism, species, and condition. And as the third step is that you should provide a human understandable definition of the variable. So you really write down what this is about. This is really important. And then look at our variable design patterns GitHub repo, which is at the moment empty, but we'll get content soon. And check if you find a pattern that you can apply as a template or abstract description that you can reuse. In this case, you need them to replace these abstract components with the more specialized ones for your variable. And I'm going now to present the first patterns, or also the idea behind it. So what is a variable design pattern? It's leaned on, or is reusing the approach of the ontology design patterns, or to have templates as starting points for your modeling situation. So you can see here So a variable design pattern would have an abstract variable and also a property, but the entity would be a superclass that you can really use directly for your description. And also, yeah, and this applies for each type of entity having different roles in your variable description. So when you apply this concept to the notion of portion, we can have a variable pattern for portion. So the portion of an entity in an entity, one in entity two. So portion would be the property and has object of interest is first entity and the matrix is the second entity. And if you apply this in the soil domain, for example, for the delivery ratio of soil erosion in sediment of a catchment, then the portion would be the property. The first entity would be soil erosion and the second entity would be sediment. You could also reuse this portion and make it more precise and say, do you use the concentration variable design pattern, so concentration of a substance in an organism, for example. So the concentration is the property, the substance is the object of interest, and the organism is the matrix. And if you use that in a biochemistry domain, then you would have concentration of sulfur sulfate in Austria Edolis, a running example, where again the property is concentration, the substance is endosulfan sulfate, and the matrix is Austria Edolis. Okay, I see there an error. I have to apologize. It's not organism, the matrix, but part of organism. So that should be part of organism here. And you can also refine this concentration example by adding a constraint and a context object. Here you have the part of organism for the matrix that was missed there, wrong there. But we add here a constraint like wet and has context object, and that's the Austria Edolis in this case. Okay, this is how you can reuse design patterns. We will have more and we'll describe them in a wiki within the GitHub repository for design patterns, and which we where we also invite you to submit suggestions that we then evaluate and include in this collection. When modeling a new variable and you don't find any pattern, you proceed with step 5. So you have to identify the result value first to understand your variable better. Is it a quantitative or qualitative value, and what does it stand for, and does it have units? So for quantitative variables, the result value is a number, and it might be associated to a unit. And the unit helps to identify the property which is observed. So for example, liter for volume. And for qualitative variables, the result value is a literal and representing a specialization of the variable. So if the variable is cell-shaped, then the result value might be spheroid. So this is could be like a controlled list under the variable cell shape. Very often used in thesauri, like LifeWatch thesauri for the biodiversity domain. And by exclusion procedure, you continue to identify the property. So the property is a generalized characteristic expressed by the result value. So, for example, if it is this qualitative variable cell shape, then it's shape, and shape is more general than cell shape because it is not further constrained to cell. Also, concentration is a more general concept than concentration of a substance. So the concentration of the substance would be the variable, and the concentration is the property that you need here. And then you continue to identify the object of interest. If you have the property, then it's easy to identify the entity whose property is observed. In this case, the substance, because we are talking about the concentration of the substance. And then you continue with the matrix. The matrix is the entity which contains the object of interest. So it's a part of the organism. In this case, it's, we had the flesh. The identity of, then identify the context objects, so the entity which further describes the variables gives the context or the environment in which this is observed, so the species. And then identify any constraints which might confine specific entities of the variable, in this case, wet. And then next step is to create your variable concept. You create it in your own terminology and associate to terminology concepts for each components using the IODOP relations. So this has property, has object of interest, has matrix and context object, and has constraint. And for SCOS vocabularies, you might ensure that your vocabulary editor accepts non-SCOS associations by adding the namespace of the IODOP ontology. It might be not always easy. We have solutions and built vocabulary services like the OnStack service. But essentially, this is possible to do. Very often, editor only allows SCOS associations to be displayed, but this is just a tool issue and not a problem of the linked data approach. Then next step, if you want to find appropriate terminology concepts, use our terminology catalog to find appropriate concepts. For sure, this terminology catalog has to grow, and it doesn't contain everything, but it's a possibility to look up. You can also use any other terminology which is not listed there, but this is a possibility to support this. As you might have seen, we don't differentiate between context, object, matrix, and object of interest as a filter, because we have just the entities as a filters, because these are just roles, and therefore it makes not sense to make this more detailed on the role. And next step is you label your variable, and you can use we would advise you to use two labels, one preferred and one alternative label. The preferred could be the one that your community is used to. But you must be very sure that this is the really same concept that you are going to label here. And the alternative label should contain all components in its label using a logic throughout your terminology. Which logic you apply is up to you, because the label is just human readable, it's not a machine readable property, and therefore yeah, you can use this, what we suggest here, but there are also other possibilities. Here, I concatenated the property with of, and the object of interest, and the in, and the matrix, and of the context object. And if you have a constraint, you would then put it before the matrix, or for the context object or the object of interest, wherever the constraints is applying. This is just one way, as I said. There are also others like CF standard names. So whatever fits and helps you to label, you can apply here. And when you want to extend the variable, because you need to have it for your observation descriptions, and you want to have the variables also including the units and other components which are not included in IADOP, you can still do this, but be sure that it's not an IADOP variable, but it's an extension of it. So you can take the IADOP variable and add a unit. And then you have to use properties associations, for example, from SOSA, to be included in your terminology. So you could have the concentration of endosulfan sulfate in flesh wet of Ostrea edolis with the microgram per kilogram as a unit. Then we have, you can also, if you have the case that you have already a concept for your variable, but you want to align it, then check our alignment GitHub repo, which is at the moment also empty, but will be populated with these and other alignments, mappings, like the IADOP to SOSA, IADOP to complex property, and this will be also explained more extensively as wiki pages for each of the alignments. We did it also for SVO, to OBOE, and other standards. Yeah, and last but not least, you can also check our implementation GitHub repo, which will include all the implementations over the next, so what we are going to do. So the first implementations we are working on are ENFDES, the environmental thesaurus for the long-term ecosystem research. I will talk about this later. I'm also extending ENFDES with Moneas variables for surface emissions. Then we have the NERC vocabularies and CF standard names, so a use case which will be presented right afterwards. And the Pangaea, the next also use case presented today. And there are other implementations planned, like the OMOP implementation guide extended with the IADOP, the OMS, that's observation and measurement extended with IADOP in the new version, and EML property extended with IADOP under discussion with the US LTR. So this is something which we have still to explore if this will happen. Thank you. Now I give over to Gwen again, or if you have any questions, please let me know.
Yeah, maybe if anybody has any question for Barbara, maybe we can ask them now.
And Gwen, I prefer that you present your your use case and also Robert, because we never heard about Pangaea. And if there's still time, I will present the ELTA standard observations, okay?
All right, okay.
Because we have only 30 minutes left.
That's okay. All right. Mm-hmm. Okay, can you stop sharing,
yeah.
Barbara?
Yeah, yeah.
Okay, can you see my screen?
Yes,
yes.
we can.
Yeah, okay. So yes, I'm going to talk about the adoption use case within the NERC vocab server. I'm going to try and be brief So basically, we're implementing the IADOPT framework in order to address a difficulty we've had in the past in aligning climate and forecast standard names vocabulary and the BODC parameter usage vocabulary that is used by the CDataNet Marine, the CDataNet community, and as well as others. So we've got two communities here, and they use two different metadata standards that are backed up by two different parameter labeling schemes. So the CF standard names and the BODC parameter usage vocabulary. Both of those have now been adopted by others, so they've got a growing community of users. They are both now governed through discussions that happen in GitHub. Both those vocabularies are very structured, and they are ruled by different models, if you want. So the CF standard names rules is based on the composition of CF standard name is based on a series of rules and grammar, while the BODC parameter usage vocabulary is backed up by a semantic model and a series of control vocabularies that operate very similar to what we've been talking about for the IADOPT framework, but in a much more detailed way. So both those vocabularies are managed via the NERC vocabulary server. So those two, the CF standard names they were developed to serve the format used by the climate modeling community. And they cover both atmospheric processes and oceanic processes. And more as well, they cover observation measurements. And the BODC parameter usage vocabulary, it was mainly designed for observation measurements, but they also can have some modeling or simulated measurements. So there is, and also as well, it deals with the marine atmosphere as well. So there is a thematic overlap between the two. And we really need interoperability between those two major vocabularies. So this is just an example of the structure of the CF standard names. I won't go into the detail of it, but it is very, as I say, very fairly detailed information held into the CF standard names. And here's the same for the BODC parameter usage vocabulary. So what we did, so as I said, those two are managed through the NERC vocabulary server. And here you see two screenshots of two concepts from the two different vocabularies. So we have the usual information like preferred label definitions, all the dates and version numbers, then whether they belong or not to schemes. And then we've got the scores relationships that are associated with those concepts. So what we did is to implement in the NERC vocab server the ability to deal with non-scores relationships, and we created an attribute conforms to, which enables us to express the relationship in more complex relationship than just the scores one, which are broad, narrow, same as, etc. So in this case, this is currently not live, so you wouldn't be able to see it if you were going to the NERC vocab server, but we are implementing the IADOPT framework as a profile, which means that users will be able to click on an alternate profile here and see the expression of the relationship associated with, for example, the CF standard names based on the IADOPT relationships or properties. So, and then it will be possible to also access those profiles in different formats as well. So it will give a choice to the user. So here, this is just a screenshot of how it could potentially look like. So you see here the IADOPT property as constraint, as matrix, as object of interest, as property. And this is associated with this is actually an essential ocean variable concept, which is oxygen. So oxygen in the EOV as property concentration, as object of interest oxygen, as matrix water body, as constraint, dissolved plus reactive particulate. And those will then be mapped to the CF standard names and the BODC parameter usage vocabulary, enabling interoperability and also aggregation between those different vocabularies. So this is a framework for implementation. So we will add the IADOPT ontology properties to the NVS. Then we will map the CF standard names and the BODC PUV to a set of common terminologies using the IADOPT properties. Then we will reuse existing terminologies as source of the atomic terms. We will then identify design patterns to make the process more automated. And we will publish the mappings to the IADOPT, the mappings as a profile on the NVS. And then we will develop SPARQL queries to enable smart mapping between CF standard names and BODC parameters usage vocabulary. And when this is done, it will give us interoperability with other vocabularies that are using the IADOPT framework as well. So the potential is massive. So this is just an illustration of with some examples. So I will pass on to, I will stop sharing and Robert maybe can.
Yeah, thank you, Gwen.
All right.
Let's see. Yeah, so thank you. This is, I think, the second time I had the opportunity to introduce to the potential adoption of IADOPT for Pangaea. Well, as you can see here, most of the work has been done by my colleagues I'm presenting here. I would like to start with some introduction on Pangaea quickly. So this was founded almost 30 years ago, and it is managed and operated by two institutions, Alfred Wegener Institute in Bremerhaven and the Marum Institute, which is Institute of the University of Bremen. Both are in Germany and relatively close by. So the focus of the system is on marine and environmental data. We hold about 500,000 scientific data sets now, and Pangaea is certified as a long-term data archive by the Data Seal of Approval, for example. It's a member of the World Data System and an approved data archive for the World Meteorological Organization for radiation data. So this is an overview on the nature of data Pangaea holds. I will not go into too much detail, but as you can see, it is extremely heterogeneous. It is ranging from data which has been measured or collected in the biosphere, atmosphere, hydrosphere, and lithosphere. So focus here is, of course, on the hydrosphere, because the origins of Pangaea are clearly in the marine sciences. So, so the nature of data is ranging from sediment data to biodiversity-related data and geophysical data. So it's really heterogeneous. So this is how a typical data set in Pangaea looks like. So every data set is labeled with a DOI, and at the heart of each metadata and also of each data set are what we call parameters, and this is exactly the same kind of string we just heard before from Gwen. This is describing a measurement, or if we speak in terms of a tabular data, this is a typical table column header, for example. Of course, Pangaea offers a variety of other metadata. I will not describe this here in detail because the time is so limited. Well, in Pangaea, a parameter is a complex concept, and it is representing the observation or measurement itself, but also the context. So this is very similar to what we heard before. I think I do not need to describe this in detail, but some examples here of our parameters, like this material biomass production of carbon, standard deviation, and so on, I think nicely illustrates that we all have the same problems, and that IADOPT is very well suited to help us to structure this in a better way in the future. because as you can see, these parameters basically are strings which are really, well, minimally structured. So what we did was we started to semantically annotate parameters. So the idea was to link external ontology information to parameters. But it was quite challenging because we in the moment have more than 160,000 parameters, and manual annotation is really a challenge or impossible. So our approach was to do this in a hybrid approach, semi-automatized, well, and well, have machines do the most of the boring work. So what we did was we extended the data model of Pangaea, as it is shown here. Basically, it's about well, relating terms to, or semantic artifacts to each parameter, and well, define the type of relation and so on. So we additionally implemented harvesters to cache external ontology terms, as you can see here on the list of the right side, which is, for example, from WORMS, which is basically a taxonomic database, and ITIS, but also classic environmental ontologies like NB, JB, and so on. So we harvest these ontologies at a regular basis. And for each of these ontologies, we developed dedicated harvesters in order to map them later with the parameter name. So this is a short overview on how actually this semantic annotation, this machine-based annotation works. So Arno has developed a web service for this, which is taking a parameter string and as well the associated unit of measurements, and then tries to identify individual terms and checks if these terms are listed in the ontologies we have cached here, and is making then the relations between the terms and the parameter name. So this example here shows it. The parameter name is Abietyrina CF pulchra. So the tool correctly recognizes the species name and well, identifies this term in the WORMS ontology. So this is also then available for our data curator, which then can add additional terms, like, for example, here, this individual density term here, or can make changes and quality checks and corrections. So this is basically the hybrid approach of our semantic annotation exercise. So this is how we expose this to the public in the moment. So if you hover with the mouse over one parameter name, so you will see a pop-up window which gives links to the external ontologies. Again, with this example, if you would click here on the species name here, it would lead you to the WORMS entry, which gives you more detail about this name. Yeah, so this is a screenshot how we in the moment expose this in our metadata. We are using schema.org JSON LD to do this, and we are using well, this subject of and has defined term way to expose it in the metadata. But this is exactly what we will work on during this use case. We will try to find out how we can embed adopt schema in either schema.org or other metadata standards like DCAT or whatever. And this is the way how we hope we can improve our metadata quality. And as Gwen showed before, the ultimate goal is, of course, then to map this with others, with CF variables, with the parameters delivered by the BODC and so on. Yeah. So thank you.
Thank you very much for this, Robert. So I'm curious how this would work to extend schema.org with IADOPT. So are you part of the schema.org initiative?
No, it's not really about extending schema.org, but I think we need to see if we can, because it's JSON LD, we can just use other terms or link it here. So this is exactly what we are going to try to investigate during the next months.
Okay, thank you very much. So any other questions? We are quite a small group today, which is unfortunate, but because probably we are very early in the morning. But if there is any question, yeah, it would be good to know. Otherwise, I would continue with the presenting the ELTER adoption of the framework, and also show how I do it practically. If I know that's, I think not so good. Okay, you see my screen now, hopefully. Yes.
Yes, we see your screen now.
Okay. So ELTER is the long-term ecosystem research in Europe. We have lots of environmental data where we need to provide semantic interoperability. And we have, our network has is represented in over 26 countries and has in total we have 450 sites and 35 platforms, and all produce lots of parameters or variables, which at the moment are not really using any specific procedure or standard way to denote what they are doing. So we have a variety of these for being able to standardize the quality also of the observations. Lots of work has been done to to identify really the key variables that need to be observed for which are really relevant for our mandate to understand ecosystem, terrestrial ecosystem. And Stefan Zacharias from ELTER has led this work, and they come up with 173 candidate variables that we will call ecosystem standard observations, or will also then get the label of ecosystem essential variables, similarly as this essential biodiversity variables. We will have essential ecosystem variables. And here you see also the compartments, the different compartments in which this will be divided. So there are abiotic heterogeneity, biotic heterogeneity, water budget, energy budget, matter budget, and socio-ecological socio-ecology. And for all these, we will have different variables that we will then also start to describe and represent with IADOPT. And here an example, a concentration of total phosphorus in horizon A. I provided together with Stefan Zacharias a human description. I minted this in ENVDES as a concept, as a variable, and then I decompose it in a property, in a constraint, and object of interest in the matrix. So the property is the concentration of phosphorus, but it must be total, because we are looking at all phosphorus fractions, so total soluble phosphorus and particulate phosphorus, and then we have also a matrix that's the horizon A. And for these, I have also already had these concepts in ENVDES. I just reused it to describe this specific variable. So this is how it looks like in OntoStack. So here again, you have the UI of this concept. You have a SCOS concept, which is the broader concept, the concentration of the total phosphorus, which is then specialized in for the different horizons. And yeah, and you have here this IADOPT associations, has object of interest, has property, has matrix, has context object, and has constraint. And I can show you now how this looks like, because I think that might be interesting how this looks like, but I have to stop share. So I'm not totally sure. I think I can do it like this. Please tell me if you see an Excel sheet, a Google Sheet. Can you see a Google Sheet?
Yes, we do.
Yeah, perfect. So this is how I do it. So how I work with the variables, I use a Google Sheet with which has a header with all the prefixes I'm using for this terminology. So I'm using the prefix ENVDES for this environmental thesaurus, and then I'm also having DC terms, for example. But I also introduce, oh my God, that's not ENVDES, that's IADOPT. Okay, that's IADOPT, the IADOPT ontology, yeah. No, okay, sorry. Here, the prefix, interoperability, IADOPT prefix is EOP, and this is then, this enables us to reuse the associations in this sheet. And to be able to show you how this looks like for each of the variables, I have to hide this first, the header, because otherwise you can see it. And if here you can see we have here one identifier for the concentration of total phosphorus in horizon A. We have the human readable definition, and we have here IADOPT associations, has property, has object of interest, has matrix, has context object, and has constraints, where I can add either concepts out of ENVDES by just using the this name, this prefix, or using directly links to existing other ontologies. And once I have done this, I can use a tool called Sheet2RDF, and which has been developed by a colleague of mine with already existing scripts that he adopted it for our use case. Then you can create out of this, with this procedure, a turtle file that is then imported in the ontology, this editor. And we are using now OntoStack for this. And here in OntoStack, you see how you can look for it. ENVDES has these top concepts at the moment. Yeah, and the variable has is here. Has here different sub concepts like at the moment still called parameters because I have not adopted it for all of the entities variables, but you can then find here the concentration. Sorry. Of total phosphorus in horizon A, and you can see that this is under the chemical parameters, and you see how this is displayed here in this ontology. I think that's quite nice and reusable also for other contexts. I think that's it from my side. I have at the end of the presentation links to our resources and GitHub resources. We have all the links also in the common notes. And I would like to give over to Gwen also to see if there are any questions that arose in the meantime. Very quiet today, right?
So something we haven't, that was on our agenda is to discuss our future plans. So, I mean, the work group is officially finishing in November. So we are working on our recommendation document and on finalizing all our output. But as you've probably gathered from what was presented, a lot of the work is going to be to carry on beyond the lifetime of this working group. So we were born from VSIG, from the VSIG stands for Vocabulary Semantic Services Interest Group. As I put in the chat there, we've got 10-minute slot to present IADOPT at the 2 VSIG sessions next week.
Are you going to do this, or have we split this? I think we have split this, right? Yeah.
So, so basically within the session, we will discuss the future of the work and our intention to carry on as a task group under VSIG, and to maintain that working group in an informal way somehow. But there is still a lot of work to be done. So we are still very invested in that work. So so basically, if you want to be involved, it's worth it. Even if you're just starting now, it's worth being involved at this stage. If you want to implement the IADOPT framework or see how it could be implemented in your systems, then we welcome that as well, and we will help you as much as possible.
Yes, we can also add that there are some attempts there to already build services, as I have shown here, also for ENFDAS, but for including these external associations. But also, I think for labeling or reusing existing terminologies when building an IADOPT variable. So there are some ideas already, but we need some resources, and we are applying for projects. And should we show also our recommendation document, how it is structured, just to have a look at it?
Yeah, we can.
Can you share that?
I need to find the link.
Okay, otherwise I can probably. Any questions from the audience?
Okay, I've got it now. Great.
Can you share?
Yeah. Can you see it now?
Yeah. You should just make it a bit
Bigger.
Larger. Yeah. Yeah.
So basically, this is our recommendation document as it stands at the moment. So we've got the usual structure. So we will detail the methodology. Then we've got a section for all the outputs. So that those are the outputs that will be maintained beyond the lifetime of the working group. And then we've got a section on recommendation, which we still need to work on. At the moment, our recommendations are quite narrow, targeting a specific use case, but we want to make them more general. So we are working on that. And then we've got a section where we talk about the connection with the other RDA recommendations and working group, which is also work in progress. And we need input from everybody here. So if you see some obvious connections, please just contact us by email. And then continuation and future work. So I'm just going to scroll through. So the methodology, and we've used as much as possible. In fact, instead of putting a lot of information in the document, we're actually relating to our GitHub repository, especially for things that are going to be updated beyond the lifetime of the working group. So this is what things that you've seen over the course of this session. So here are the alignments to other ontological frameworks, and then we talk as well about relationship with schema.org. Then we've got the uptake stories, which are, some of them will remain small project-based uptake stories, but some of them, like the one we presented, we intend to actually have them as adoption use cases. And then the recommendations, our plan for continuation of future work beyond iAdopt, and then all the activities we've been involved, because we've produced those output, but it's been an intense 2 years really, and especially Barbara has been very involved in running workshops and presenting iAdopt to various. A number of us were involved in presenting iAdopt to a number of communities, and there's been a lot of interest raised around iAdopt. So it's really, we really hope that this is going to take off and implemented by many. But we realize as well that we need to first show the adoptions. So our plan for the adoption is to have something demonstrable by the beginning of next year. So for NVS, for example, it'll be February 2022. We should have something in production. And I think Pangaea, it's about spring next year as well. So early next year, we will have some demonstrable applications.
Yeah, and
you think, Barbara?
Yeah, I just want to say that we will also update this document. So the next week with all what we wanted still to finalize, but we are happy to get feedback from you before we send it to the RDA Secretariat, so that it is then overall document to be evaluated.
This document is actually, you can't edit directly in the text, but you can, everybody with a link can comment on it. So please feel free to add comments.
And what we also want is to update our wiki at RDA with the new content now, which I was not able to do, but this will be done by end of the week or beginning of next week, so that we have the new links to everything what we produced. So we were very productive, but we still have to update the information on our official site.
Okay, I think we've reached the end of the session, end of the workshop. Well, thank you very much, everybody, for attending. I hope it's been useful, hour and a half. So as I said, maybe see some of you at the V6 session next week, and please be in touch.
Yeah. Is there any last, possible comment from the audience also, Milan or?
Yes, I have one. I think you have done a lot of work And I think it's this is very useful work, but I think problem is this semantic gap between users, ordinary users, for example, one from earth science or one from bioscience, and these users don't have knowledge of how to use ontologies, how to use, for example, vocabularies. And I think we need to work on tools.
Yes,
How
yeah.
to
You're completely right. So we
Definitely,
have to do
Lilian,
this.
yeah. I think we need to
And-
make, we need to use the Adobe framework to actually build those tools. So I think the Adobe framework will enable people to build interoperable tools somehow and get access to complex semantics, but through very simple interfaces.
Yeah,
Mhm.
perfect.
Yes.
And in addition, we are doing also now in Envy Fair, we are planning a series of trainings, workshops with the researchers so that they understand how to use this. So both, you have to increase the skills and the understanding, and also provide tools.
All right. Thank you very much. I think we should close the session now.
Yeah,
So
there's a lot.
yes,
Thank you. Yeah.
just get in touch when.
Goodbye.
All right. Bye-bye. Bye, everybody.
Bye-bye. Thank you.
Bye.